Alright, so here's example 4 from our notes, graphing in standard form, ax squared plus bx plus c. Let's fill in what we can first. Alright, so we got a, b, and c here we're going to fill out. Remember, a is the leading coefficient in front of x squared, so a is 1. The fact that a is 1 and a is positive, that relates directly to my opening of my graph. So my graph is going to have U-shape opening up. If it opens up, then the bottom of the graph is going to be the vertex. That means I'm going to have a minimum here at the vertex. Alright, so you get that all from your a value here. So if the a is positive, the graph opens up. That means I'll have a point here at my vertex will be a minimum, be its lowest point on the graph. Alright, and the b value here, we got the b value is 8. And the c value here is 14. Okay, we could also get something from the c value here. The c value is what my y-intercept is going to be. So 0, 14 is going to be my y-intercept. Okay, again, you find your y-intercept by plugging in 0 for x. So if you plug in 0 for x, 0 squared plus 8 times 0 is just 0, and you just left with 14, right? And you can do that either from plugging it in, or you could just get that, like I said, recognizing that from your standard form c value. Okay, what's next? Axis symmetry and vertex. We're going to get the axis symmetry once we get the vertex. Let's go get that vertex. The vertex is x equals negative b over 2 times a. Right, so I have negative, my b value is 8 over 2 times a, or 2 times 1 in this case, so negative 4. So my vertex is negative 4. Now that I have the x value of my vertex, I could get my axis of symmetry. My axis of symmetry is x equals negative 4. Right, so I'm going to draw a line here at negative 4. So 1, 2, 3, 4. So there's my axis symmetry. Okay, there's my axis symmetry at negative 4. Okay, so it means my vertex is on this coordinate somewhere, on this point somewhere. Let's see where it is. What the hell? What's this glitching? Alright, so now I'm going to plug in negative 4 into my equation here. If I plug in negative 4 into my equation, I get negative 4 squared plus 8 times negative 4 plus 12. If you want to pause for a second, do this on your calculator, you end up getting negative 2. So my y value is negative 2. So on my graph, I got negative 4, negative 2. So there's my vertex. I'm going to label this coordinate for myself. I got negative 4, comma, negative 2. Alright, so there's my vertex. And this line goes on forever. Okay, so let's see what else we got. X-intercepts. So remember, x-intercepts are going to be the same distance away from the x value of the vertex. We could try factoring this, but I can see that my leading coefficient is 1, so I could easily factor this, but there's nothing that factors into, or there's no factors of 14 that give me 8, right? Factors of 14 are 1 and 14, that does not give me 8. 2 and 7, that doesn't give me 8 either. So I could use the quadratic formula here, or you can complete the square. I'll go with the quadratic formula, why not? So I'm just going to write down the formula for myself, just to remind myself. X equals negative b plus or minus square root of b squared minus 4ac all over 2 times a. Alright, so there's my quadratic formula here. I'll move this up for myself, put it up here for a second, and I'll fill in the rest. So x equals negative b, so negative 8 plus or minus the square root of, alright, b squared minus 4 times a times c all over 2 times a. If I take this a little further, I get negative 8 plus or minus, if you do a squared minus 4ac, you get the square root of 8 over 2. I'm just going to stop there for a second. The reason why I couldn't factor this was because this piece here, the square root of 8, this was factorable, I would have got a nice number here. I would have got the square root of 9 or square root of 25. I would have got something that would have worked out. But because I got the square root of 8, I can't take the square root of 8, so that's irrational, right? So this is why I can't factor this. So I'm going to get two estimates here. I'm going to have to estimate this on my calculator and see what I get. So if I do negative 8 plus the square root of 8 and divide by 2, I get negative 2 point, and it's going to be 5857, blah, blah, blah. I'm just going to round this to the nearest tenth, so I'm going to just say about negative 2.6. And if I do negative 8 minus the square root of 8, I'm going to get negative 5.4 if I round to the tenths again. So again, these are two coordinates of negative 2.6, 0, and negative 5.4, 0. And again, my vertex is a negative 4. I'm going to be, again, negative 2.6, negative 5.4 about the same, or are the same distance away. Right, so negative 2.6 is 1, so negative 1, negative 2, negative 2.6 is about there. And 5.4, I got 2, 3, 4, 5, 5.4 is there. Alright, so they're both about 1.6 units away from the axis symmetry. Okay, so now I got myself vertex, two coordinates, y-intercept, which is 14. Let's see if I have enough spaces here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my 14 is right here. So if I'm noticing my axis of symmetry here, right? So I am 1, 2, 3, 4 units away. Right, that's 4 units away from the axis of symmetry here. So if I count another 4 units away, 1, 2, 3, 4, I should also have a y value of 14. And again, this is 0, 14, right? Because this is my y-intercept, which is 4 units away from negative 4. So if I go, that's going 4 units to the right of negative 4. If I go 4 units to the left of negative 4, this will bring me to negative 8, 14. And again, you could easily verify this. If you plug in f of negative 8 into your function, you will get 14. And now I have a reflection point, which is negative 8, 14. So I got my vertex and two coordinates to the left of the vertex, and two coordinates to the right of the vertex. That's going to be more enough for me to make my graph here. Right, so let me just draw my U shape up, going this way. Do my best to draw this U. My U shape up this way. Right, this one's going to go all the way up. 14. And down to 14. Alright, so that's what the general shape is going to look like. So I got everything I need to graph this, and now I'm going to fill in the rest of this. My domain and range. So my domain, I can plug in any x value I want into this function. Right? I don't have any restrictions here. It doesn't, what can you plug into this function for x? Anything you want, and you will get back some kind of y value. My range, well, after plugging in any of these values for x, no matter what values of x I plug in, my smallest y value is going to be negative 2, which is the bottom of my vertex here. So the lowest will be is negative 2, and then the highest will be way up to infinity beyond there. Okay, then we got the other piece here. Where is the graph increasing? Well, remember, you read a graph from left to right, and if I read from left to right, this part here, so what's happening to all my y values here? All my y values here on this part of the graph, all my y values in this part of the graph are going down. Right, so as x is getting closer to that vertex, right, so as all my x values are getting closer to negative 4, all my y values are decreasing, right? So here's negative 4, negative 5, negative 6, negative 7, here's negative 7 somewhere around here, negative 8's around, negative 6 is around here, right? All my y values are going down here. So, and then on the flip side, once I pass this vertex, then my y values start to go up, which means it's increasing. So after the vertex, so from -4 to infinity, so after the vertex, all the y values are going up. Before the vertex, so from negative infinity, sorry, I wrote that in the wrong spot. Increasing, decreasing. So from negative infinity, so from -4 to infinity, everything's going up, and from negative infinity to 4, right? So negative infinity to 4 is after the vertex. Negative infinity to -4 is everything before the vertex. So everything after the vertex, the y values are going up. Everything before the vertex, the y values are going down. Alright, so now it's saying the next piece here is, where's the function f of x greater than 0, less than 0? Alright, so in other words, where does the function have y values greater than 0? So where does the function have positive y values? So everything from here to here, and I'm going to draw in red, right? All these values of all these y values are positive. Right? All these y values are positive. And everything before here, and then everything below, all these y values here are negative. Alright, so and now I want to write that. So, and then I have some spots here, and nothing's happening at the vertex, or at these x-intercepts. Right? At these x-intercepts, they're actually just 0. They're not bigger than 0, they're greater than 0, they're just 0. So I want to say that. So everything up from this graph here in the red, so from negative infinity to the x-intercept, so where's it greater than 0? So from negative infinity to this x-intercept of -5.4, everything has a y value of bigger than 0. Then from -5.4 all the way to -2.6, all the y values here are negative. And then after 2.6, they start to, all the y values are positive. So back to here. So from -2.6 to infinity, all the y values are greater than 0 again. So this piece here is from negative infinity to -5.4. This piece here is from -5.4 to -2.6. And this piece here, after a union, is -2.6 to infinity, right? So this is where the x values are. This is where f of x is bigger than 0. This is where f of x is bigger than 0. And this is where f of x is less than 0. Alright, and that's all the pieces that we need for this graph here. Right? All this is going to, the only thing that's going to change in this is how you find your x-intercepts. And just remember, you have different techniques. You could use this. You could use your different completing the square. Hopefully this all makes sense. All right, see you guys in class.